So now another definition. We're going to be looking at traversable graphs. So what does traversing a graph mean? Well, it means finding a trail, a circuit or a cycle through the graph, and it goes along all the edges but only once. When talking about traversable graphs, we must make sure first of all that our graph is a connected graph. If it is not connected, then it is not traversable. So here are two ways we can set about working out whether or not our connected graph is traversable. Here's the first one here. So the first criteria is that all of the vertices are of even degree. So 2, 4, 6, so on. So all of the vertices are of even degree. Our second criteria states that they could have 2 odd degree vertices and the rest could be even. So if our graph falls into either of those 2 categories, then we would consider our graph to be traversable. Okay, so it has to be either of those 2. So let's have a look at an example on the next page. So the question asks in 1 to determine whether the graph is traversable and state why, and then if it is traversable to find the trail or circuit that goes through it. So let's have a look at A to start off with and work out the degree on each of our vertices there. So remember, degree is the number of edges that goes into the vertices. So 2, 2, 2 and 2, which really means there that all of our vertices are even, so it is traversable. So it doesn't matter where I start really, but what I need to do is go through every edge only once. So if I started from here and went that way and then along that one and then that one and then I go back to where I started from, I have crossed every edge in that graph only once. The next one, let's do exactly the same way and work out the degree on each of our vertices. Now remember, we're only dealing with connected graphs. This is connected. It's not planar, but it is connected. So degree of 2, degree of 3, degree of 3, degree of 2, degree of 2. Well, the 2 criteria were that you had either all even vertices or 2 odd and the rest even, and that's what we've got here. So it is traversable. All right, for this one, I might start here and I'll go this way, this way, this way, this way, and that way, and up there, which means that my graph has used every edge only one. Remember, this is not the only trail I could have taken, but it is one of many. So let's do the last one here. And again, we'll start off by working out the degree on every vertice. So we have 3, we have 3, we have 2, we have 3, and we have 3. So we've got 1, 2, 3, 4 odds. So it doesn't fit into any of those criteria that we talked about, and they were all even degrees or 2 even and the rest odd. So because we have 1, 2, 3, 4 odd, then my graph is not, and I therefore can't find a trail or circuit through it.